Angles and gradients, they're related because the angle between a line and the x-axis is given by the inverse of the tan of the gradient. And we mean the angle that's to the right of the line, or in other words, the angle between the line and the positive x direction. So in this case here, if we're after this angle in here, and we're told our gradient is 3 over 4, that means from here to here, we went across 4 units and up 3. We're after this angle here. Using trigonometry, we label our triangle. That's the opposite, that's the adjacent. We know our opposite side is 3, our adjacent side is 4. So we find arctan, or in most calculators that's shift tan, 3 over 4, and we get 36.9 degrees. Going back the other way, if we want the gradient of this line here, and we're told that this angle here is 30, the first thing we have to do is find this angle here, the angle between the line and the positive x direction. Angles on a line add up to 180. If this here is 30, that there must be 150, because 30 plus 150 equals 180. So we take that tan of 150 degrees. Tan of 150 degrees is negative 0.577. So the gradient of this line here is negative 0.577. Now you have to be careful because calculators handle negatives in a different way. So you have to check which way around your calculator works. I always do a diagram. For question 2D, we were after the gradient of this line here, and we're given this angle here is 70. If that there is 70, this here must be 70 by vertically opposite angles. By angles in a triangle make 180, that there must be 20, remembering we have a right angle in there. If that there is 20, this angle here must be 160 by angles on a straight line equals 180. So we take the tan of 160, and that equals negative 0.36. So the gradient of this line here is negative 0.36. Remember, we need the angle between the line and the positive x direction. In question 2C, we were told that this here must be 40. Is 40, which makes this angle here 40 by vertically opposite angles. We've got a right angle here, which makes this angle here 50 degrees by angles in a triangle equal 180. We take the tan of 50 degrees, which is 1.19, so the gradient of this line here is 1.19. Question 3C. We have to find the angle between this line and the positive x direction. We're told that the gradient is negative 2 over 3. So going between any 2 points on the line, if we go down 2 units, we go across 3. First thing we do is we find this angle here by trigonometry. So we find the inverse of the tan of 2 over 3, and we get 33.69. This angle here is 33.69. By corresponding angles, this angle here is also 33.69. Angles on a triangle make 180. Get our 180, take away our 33.69, and we have 146.31. This example here I've made overly complicated because if we draw our triangle so the base is the x-axis, it makes things a lot simpler. So in question 3H, we were told that the gradient is negative 1 over the square root of 3. So going from here to here, we went down 1 and across the square root of 3. So we find this angle here first. We go shift tan 1 divided by square root of 3. and we get this angle here is 30 degrees. If this angle here is 30 degrees, by angles on a straight line making 180, that angle there is 150.